now we're back to here, and again, our goal is we want to try to find the area under this particular curve. Actually, let me make this bigger. We're looking for the area inside the blue here. And we're going to break it up into 4 pieces. Now, I want to break it up into 4 even pieces. So where am I going to break it up? Something like that, right? They're supposed to be evenly spaced. My drawing isn't perfect. In fact, there's one rectangle. There's 4 rectangles. You would agree our answer is going to be too large. Yeah. This step size, I'm calling delta x, in this case, is 1/4. There's actually a formula on how to get that.
This is minus a.
What's that?
Is that minus a?
Yes, b minus a, and this is here's our a and b. So if it wasn't as obvious for us that it was 1/4 and we had to calculate it, that'd be easy. We would just go 1 minus 0 divided by 4, which is 1/4. Because we're going to get more complicated ones here in a minute. Yes?
Will you, like, on a test, like, tell us what end that you want?
I'll have to give you the boundaries.
For sure. For the end.
I'll have to give you the end. Yes?
Why couldn't we instead just use triangles? Like,
We could try triangles. Trapezoids actually is another way to do it as well. But for right now, we're just going to use rectangles. And you'll see where I'm going to. Now, again, our answer that we're going to get, it's going to be too big, right?
Yeah.
So in this case, I also want to point out,
I don't have very nice fingers. Okay, I got white out. I guess you're gonna get Oh, I need to.
Yeah, put it up again.
right? These are the heights.
Help a girl out, Jody.
And right here is going to be f of 0. And up here is f of 1.
F of 0 is the origin point, right?
F of 0 is 0 in this case. It's at the origin in this case. That's not always the case.
Right.
So the area of a rectangle, of course, is base times height, or length times width, however you want to say it. In this case, it's delta x, right? So I'm going to call this area 1, area 2, area 3, and area 4. 1/4 times f of 1/4. This one's going to be 1/4 times f of 1/2.
It's like when you plug in the number of x into like a line equation, that's like going to be the value. Yeah, I think you're right. You're basically just finding areas of rectangles right now.
Notice they're all multiplied times 1/4. That's because we're choosing to have our step size the same size. In really high-up mathematics, we can actually pick our step sizes as big or large as we need, depending on what we're doing, but that gets a little complicated.
Should the step sizes always be the same?
Say it again?
Should the step sizes always be equally like the same?
For us, and all you engineers for sure, they're going to be the same every time.
Okay.
Yes?
Is that for accuracy? Like,
You mean that they're all the same?
changing the steps, like, how many steps you have,
Uh,
be more accurate?
Are you asking about,
Yeah, if you increase that.
if you increase that, then you should increase the accuracy. And we'll get all into that. Okay, I'm going to notice that I'm going to add all these up, right? So I'm going to end up with 1/4 times f of 1/4 plus f of 1/2 plus f of 3/4 plus f of 1. And that is going to give me my total area. I just factored out the 1/4. The delta x, as it were. F of 1/4, when I square it, I get 1/16. F of 1/2, when I square it, I get 1/4. F of 3/4 is 9/16 when I square it. And f of 1 is 1, because 1 squared is 1.
Can we use a summation formula for that?
Oh, for sure, yeah. Yeah, we're going to have summations like crazy today. Let's see. So that's going to be 4, 5, 14, plus 16.
You put all that back into the original equation. So
And that's going to be 15 over 8.
So you put it back. It's going to 1/4 squared. That's 1/16.
And this is too much area, right?
Right.
Yeah.
We don't even know how much.
Why did you square?
It's too much at this point.
Because it's the original function.
The actual answer is actually 1/3. Would you please divide that out? Let's see how close or far away that is from 1/3.
Will we normally have units with this?
What's that?
Will we normally have units in that answer?
No.
No.
Because the area itself actually isn't what's important. But what's actually important is this result.
Okay.
Were we close? To 1/3? What'd you get as a decimal? Yeah, it's pretty off, right? So we're close. It's way too much. So we can redo this actually and do it a different way. Since we got too much that time, let's see what happens if we get too little. Again,
Arm cramping on your machine. I need burritos, dude. I'm just saying, Kevin's gonna smell it. He's gonna smell it.
now we're going to draw the rectangles a little differently.
That's weird.
Notice we are missing a lot. Delta x is still the same, right? Delta x is still 1/4.
iPad's
Notice the rectangles are actually the same, they're just all shifted over.
Right.
Add them up. So it's going to be 10 plus 4 is 14 over 16. 24. Wait, that,
Mm-mm.
that's 10 over 16
4 over 16.
plus 4. 10 over 16 plus 4, 10 and 4 is 14. 14 over 16, which is 7/8. Okay.
Kevin,
Yeah,
how'd you get 1/10?
that's the 16. Sorry. What is 7 divided by 32? Is that 1/3?
No.
It'd be way less, right? So this is too much, this is too little. So let's do this now. Let's take the average. See what happens. Maybe it'll balance itself out, kind of. So would you please add up 7 over 32 plus 15 over 32, and then cut that in half? You're going to add them up and divide by 2, right? The average them?
That means 11 over 16.
Yeah, so-
Can you ever get
What do you get? Let's see, 7 plus 15, 22 over 32, 11 over 32. So what's 11 over 32? So that's pretty close. Way too little, way too much. Average amount, we get something kind of close.
Okay, I was gonna get the same denominators.
Not necessarily. It may reduce everything. Okay? So even though we had too much, too little, and then averaged it, it still didn't come out to be 1/3. Now what's going to increase the accuracy is if instead of breaking it up into 4 pieces, we break it up into 8 pieces. It's going to be much closer. In fact, the average of the two is going to even be closer. Now, we're not going to do this again because it's so inaccurate. I'm just using it as a demonstration to show you that it's really not very accurate. Yes,
So the smaller n, or the larger the n that we have, the more accurate it is.
exactly. So if I increase this to 6, it still wouldn't be dead on, but it would be much more accurate. Yeah,
And if we increase it, we don't have to worry about what side we're putting the,
right.
okay.
Yeah. Now, if I took n and made it 20, it's going to be way more accurate. In fact, there's going to be very little room for errors. It's going to be like steps walking down, right? What if I made n 100? You can imagine doing that by hand. So if n's 100, it's going to be even more accurate. How about 1,000? There's going to be almost no error, right? Very, very little. So what we are going to do today is we're going to try to say, hey, let's push n all the way to infinity. And then it will exactly be that. So that's where we're headed for now. All right.